Hey guys, my name's Jay Wilson. I'm a freelance consultant through my company, Onyx Reporting. Today I want to share with you guys some of my thoughts and experience working with pipeline optimization. In particular, we're going to talk about partitioning and UPSERT. This video is going to be somewhat high level, but it's targeted at people who are dealing with building data flows in Domo and people who are asking themselves, hey, why am I not getting the performance out of the system that I don't? This video is targeted at people that work with Domo in terms of optimize. This video is targeted towards data specialists that are building data flows in Domo, but is particularly going to be valuable for people who don't like Domo yet. I'm thinking data engineers, SQL DBAs, and whatnot, who have all of their experience from working with other systems, who then look at Domo and are like, yeah, it builds good visualizations, but the backend is rubbish. So if that's you, stay with me for a sec. I hope you'll get something interesting. Again, we're going to be looking at partitioning and UPSERT, or as I like to call it, hashtag no recursive data. Okay, so for those of you who know what partitioning and UPSERT is from your background in traditional BI, or for people who don't, before we get into like the ins and outs of how you do it in Domo, I wanted to talk about why I have so much hate for recursive data. And really, it's not just me, it's actually most of the data engineers that I talk to in general. The problem with recursive data flow is that data flow execution time scales linearly with data volume. In other words, first off, let's talk about what you use recursive data flow for. Usually, we'll see recursive data flows when you have historical data, and then you have new data that's arriving, and you want to merge the two data sets together. And currently, in the Domo training and literature and everyone you talk to, they tell you to build a recursive data flow, where in the data flow, you deduplicate your data and then output your final data set. The problem with this model is that all of the data flows in Domo do a full replace of the data set involved. So even though your new data is only 10 million rows, ultimately you are writing and reading 110 million rows, and that's why your data flows are scaling linearly. Okay, so before we get into how do I implement partitioning or UPSERT in Domo, it's probably important to talk about what a recursive data flow is and why I have so much hate for them. I don't have hate for recursive data flows. There's a place for them in Domo, but compared to the transformation and speed of data processing that I'm used to in SQL Server or SQL database engines, recursive data flows seem unnecessarily slow. So let's talk about that. A recursive data flow has the input as the output. And usually you'll see them used in cases where I have like historical data that I'm accumulating, and then I want to add new data to that data set, but I want to deduplicate it based off of a known key value. And the way you set up a recursive data flow, again, you've got new data, you've got historical data. In ETL, you'll do an append, or you'll do a rank, or you'll do a join, but you'll find some method for deduplicating that data. The challenge is that even though there's only 10 million rows of new data, the magic ETL data flow or the recursive, the problem is that even though there's only 10 million rows of new data, in my ETL, I have to ingest all of the historical data first, then I deduplicate it, and then I have to write the combined historical and new data set back to Vault. Remember, Vault does a full replace of all of the data. And that is why your data flows are taking increasingly long amounts of time to run. What they don't tell you when they demo Domo, Domo, what they don't tell you in the first couple months or weeks that you're working with Domo is that these recursive data flows, they feel really, really fast. And they feel fast because you're dealing with small amounts of data. But after a year or 2 years, once you've grown to 100 million rows or 500 million rows or a billion rows, that peppy data flow has really slowed down to like 5, 10, 15 hours. And that's the thing that we want to get rid of. So this is the Domo architecture slide. If you haven't seen it before, please give me a holler, shoot me an email or something. Let's set something up. I would be more than happy to talk you through like each of the different pieces of this architecture slide and how it fits into your business. But today, we're going to really hone in and take a closer look at the ETL transform. But today, we're really going to take a closer look at the ETL parts of the Domo architecture slide in the context. But today, we're going to take a closer look at the ETL parts of the architecture slide and really hone in on its context to recursive data. Now, when new data is arriving into Domo, whether it's from the Java CLI or from Workbench or from any of the web-based connectors, the data all goes to the same place. They all stop in Vault first. Now, Vault is most similar to the data lake and data lake technologies that you're used to. But even once the data has arrived in the data lake, it's not available in your cards and visualization. First, it has to get transferred to the database layer, Adrenaline. Now, as part of that data transfer from flat file storage into the database layer, we have to create a table, and then Domo is going to automatically optimize it by building out a cache, calculating database stats, and applying projections to that data set. So that's all happening automatically in the background. And once that's finally completed, that indexing process is what you'll see in the UI. Once that indexing process is completed, then you can see your visualizations. Then you can see the data in your visualizations and cards. And that's where you start seeing mega fast performance in queries on 100 million rows or billion row data sets that have never been manually optimized by a DBA. So Adrenaline is actually doing some really, really cool things. That has nothing to do with the ETL layer. That has nothing to do with recursive queries. So let's talk about the transformation. When you run that recursive data, again, 10 million rows of new data, 100 million rows of historical data. The first step is transfer data into that transformation environment. Magic ETL and MySQL and Redshift are not issuing when you run a Magic ETL data flow or when you run a Magic ETL, Redshift, or MySQL data flow, none of those transformation engines are issuing queries directly against Adrenaline. Instead, what's happening is Domo transferred data from Vault, from flat file storage, into your transformation engine. The engine does its work, and then it transfers the data back into Vault using the same APIs and ingestion tools that were initially used to get the data into Vault in the first place. Kind of cool to think The problem with recursive data flows is that, again, we only had 10 million rows of new data. We had 100 million rows of historical data. I have to move both of them. I have to transfer both of them from Vault into the transformation engine. Once it's in the transformation engine, then if it's MySQL or Redshift, I have to create a table. If it's Redshift, then I have to apply an index. And then, and only then, after all of the data has arrived, can I start data transformation. Once that data transformation is complete, then and only then can I start transferring the data back into Vault. Again, 110 million rows. Once the data has completely arrived at Vault, then I can transfer the data into Adrenaline. Adrenaline can run its cache stats and projections, can build out its cache stats and projections, and then I finally see the data in Cards and Analyzer. And that process of moving 110 million rows, which is increasing in row count every time I run that ETL, that's the part that's killing us. So the dream of dreams has to be to rethink or revisit, how can I cut out recursive data flows from this pipeline? The answer is to change how you get the data into Vault. And the answer is to change how the data is transferred into Vault. Now, again, it doesn't matter if you're using Workbench, Java CLI, web connectors, or arguably even it doesn't matter if you're using the Java CLI, Workbench, the library of web-based connectors, arguably even the ETL data flows or custom or enterprise apps. They're all taking advantage of the same API framework. And the same API framework has 4 methods that you can choose from. The standard methods that you're very familiar with, hopefully, are going to be replace and append. Why just replace and append? Well, remember, Vault is like a data lake. A data lake is like a folder on your desktop where you have a CSV file. If you want to update that CSV file, either you can replace the CSV file with a new one, or you can open it up and just tack on new content onto the bottom, right? Those are replace and append. But Domo also offers partition and UPSERT. So what's partition and what's UPSERT? Partition takes your historical data set, your full data set, and divides it into volumes or chunks. It's most analogous to the encyclopedias of yesterday. Remember encyclopedias? Britannica Online. Oh God, don't even get me. Okay. Partitioning is most analogous to encyclopedias insofar as it divides up all of your data into chunks. And when I have new data, I can either replace an existing volume or I can add a new volume on at the end. So what is partitioning and what is UPSERT? How are they different and where do I apply them? Partitioning divides your data into chunks or so what is partitioning? What is UPSERT? How are they different and when do I apply them? Partitioning divides your data into chunks or volumes, and you operate on the entire volume of data at once. With UPSERT, your data is divided into individual rows based off of an UPSERT key. Using UPSERT is going to feel most analogous to a SQL insert or an update. So when I have new data come along, I define the key column, the key value, and I'll say, hey, does this key value exist in my historical data? If it exists, I'll do an update. And if it does not exist, I'll insert the row onto the bottom. In contrast, partitioning, again, divides your data into volumes, like an encyclopedia. So when I have my new data come along, I'll divide my data into volumes. So I'll divide it A, B, C. And then I'll go to my historical data and say, A, that volume exists, throw it away, replace it with the new volume, B. Does it exist or not? It doesn't exist. Okay, I append it at the end. So again, partition operates on chunks, UPSERT operates on individual rows. When possible, you should opt for partitioning because operating on a chunk of data is going to be faster than operating on individual rows. So if you have clean partitions like transactions grouped by date, that's a really great example or a great opportunity to take advantage of our partitioning, so transactional data. With UPSERT, you'll usually apply that for dimensional data. And by dimensional data, I mean customer records or item records, where I'm only interested in updating rows that changed since yesterday. Now you might be thinking, oh, in traditional BI, I can do what's called an incremental load using UPSERT on transactional data. And you can, but again, testing each individual row of transactional data is not going to be as efficient as just saying replace all of the data where the date is yesterday and the date, or the date. I wanted to circle back a little bit and get theoretical with you guys one more time. When you use partitioning in Domo, you're giving Vault the opportunity to take advantage of distributed storage and distributed processing. If you know what that means, hopefully you're getting pretty excited because that's really cool to just have built into the product. And if you don't know what that means, that's okay too. All it tells you is that even though you bought Domo for BI, you have actually functionally purchased a data lake technology that you don't have to configure, optimize, or maintain. It just works with a few clicks of the keyboard. So that's kind of cool to think about. But what exactly do I mean by distributed storage? Remembering with partitioning, you're dividing your data into volume or dividing it into chunks. So instead of having one big old 100 million row CSV file, I can divide it into a chunk per day, let's say. So I have separate CSV files for every single day. And then when new data comes along, step one says partition the new data by date. And then I can say, hey, January 1st, do you exist? You exist. Okay, erase it, replace. January 16th, do you exist? Oh, you don't exist. I can append you onto the bottom. Or actually, yeah, I can just append it in the data lake. So we're giving Domo the ability to have files that are distributed or split up. And then on top of that, as the data gets pulled into Adrenaline can say, oh yeah, I can simultaneously ingest multiple partitions at the same time and then just stitch the table up together at the end instead of having to read one big old file and then waiting until that whole file gets read in. Whether you're excited or not, it's kind of cool to think that Domo can automate some of this big data stuff that you pay hundreds of thousands of dollars for data engineers to take care of, and then Domo just does it if you know how to configure it, which is why we're here for this tutorial. All right, some parting thoughts and fine print before we do the tutorial. Actually, what I'll do is I'll split this into two videos. The tutorial will be a second video that I'll link in the description below. Compared to the rest of Domo, partitioning and UPSERT will feel relatively inflexible. Once it's in place, it's in place. And you have to do a lot of mental gymnastics to make sure that it'll come out right if you decide you want to make changes. So I guess the short version of the story is wait. Some parting thoughts and fine print. Compared to the rest of Domo, partition schemes and UPSERT will feel relatively inflexible. So wait until you're confident in your data pipeline. Wait until your schemas have stabilized. Wait until your users tell you they're happy before you implement partition and UPSERT, because after that point, you're pretty much locked in and can't change your schema much. That said, if you're dealing with huge data volumes or you're dealing with a streaming data use case, partition and UPSERT are going to have to be addressed a lot sooner in order to get the speed of the pipeline that you want. Both UPSERT and partition require a key column. Some good candidates for key columns are going to be the date column or the data source name. And both of them will work best if you stick with numeric or date data type. Now, you can't have a composite key, as in two separate columns for the to define the UPSERT key. But what you can do is you can concatenate them into one column. Just again, text is a more expensive comparison. So if you're doing UPSERT on a text column, it'll just be slower than if you were doing it on a column. This makes sense. Make good decisions on your implementation. Again, if you can postpone it until your pipeline is stabilized, that's obviously the first choice. When you're doing partitioning, though, ideally, you want to have less than 1,000 partitions. And each partition, ideally, should have multiple millions of rows of data in it. If that's not the case you're in, you might not benefit as much from using partitioning, and you should just use a full replaced, for example. When you're considering UPSERT, again, SQL developers in the house, I know you just want to use UPSERT today, right now. You're like, let's use UPSERT for everything. Don't do that. UPSERT works best on data sets in the low millions of rows, again, because you have to test the UPSERT key column against the entire history of the data set, and the larger the history, the more rows. So you want to be in the low millions. If you start exceeding that, then you really want to think, can I take advantage of partitioning or some other model for handling my data update? Lastly, I led with, let's get rid of recursive data. But at the end of the day, even I, in the consulting work that I do with companies, will implement recursive data flows if it's appropriate for the use case. So there's always a time and a place for the thing. If you want to go through that architecture slide that I showed earlier, if you have additional questions about this, if you just want someone to take a look at your data pipeline or some of your data flows and say, hey, Jay, are there any opportunities for optimization? I've definitely covered some optimization stuff in my YouTube channel, but I am more than happy to set up a call where we can do some consulting work and go through the work that you've got in place. My name is Jay Wilson. I'm a freelance consultant through Onyx Reporting, and I look forward to hearing from you guys.